In this video we will take a look inside the Git folder and we'll find out how Git works from inside. So in the Git everything is built based on the graphs, and there are three main parts. It's commit, tree and blob. And right now we'll check how they work and how can we get information from this data. So let's go to our repository. So let's go to .git folder. We will check what is inside our repository. Is just two files, but Git it's a hidden folder because it starts from dot. So we can just cd git, and right now we see that we are in the Git folder. Let's check what we have inside. So in our case we have a couple of folders. It's hooks, for example, logs, refs, and a few files like head and index. Okay, let's go to head and check what we have inside. So head is not a directory, so we can get head. So in head it's a file. We have a link, it's a reference to refs heads master. So we can go inside refs, cd refs, and here we have three folders. It's heads, remotes and tags. So in our case we can go to heads master. Let's go to heads. And here we have one master file. In this master file we can see that this SHA-1 function token, and let's take a look what does it mean. Let's open new tab. Again we are in our repository. Let's call git log, and here we see this the last commit, and in our case in the head we have reference to the same last commit because we have so we can see these numbers, they are the same. It's the last commit. Also let's go back. Also we have here remotes folder. Let's go to remote, and here we have origin. Let's open it. It's a folder, and here we have two files again. So we can check head. It again is a link to origin master, and let's check master. And in master we have the same link because it's the same commit. As we already fetch data, pull data from the server, and we synchronize our local and remote repositories, we have these links for the same commit. Yes, it's the same commit. So okay, let's go to upper, and here we have also index. So in index we have some binary information. What is saved in index? When we add some file to Git with command git add, Git saves this data in this temporary index folder, and when we will commit it, it will add to Git storage in objects, for example. So we don't need it. And what is the most interesting for us right now? It's objects folder. Let's go to objects, and here we see that there are a lot of folders, and let's find out how it works. But first of all we need a bit of theory. So Git works with a commit, tree and files. So we have commit which refers to a tree, and the tree can refer to file name. It's for song.txt, and the blob. Blob it's a binary large object, and in this blob we save all data from this file. And for example, if we have a few different commits, we have the same file with the same changes, we can refer to the same blob and do not duplicate it and not create a copy. Let's take a look, for example, on this commit. We will get inside our first commit and we'll find out what's inside. So we have this commit, and let's call git show with flag s and pretty row, and we need to enter this commit token, but we don't need to copy the whole string. We can just start typing, for example 5 letters, it will be fine. And so here we can see, we can get a bit more information. So we see that it's commit, this commit, we can see the tree, what was saved in which tree refers. We see the parent, author, and committer, and also we see this comment we added. So let's go inside this tree and take a look what's there. So we can call git ls tree, and the same, we need to enter first 5 letters. It's 47. And here, as you can see, we have BLOB, which refers to these 2 files. It's readme and song.txt and this ID. To get the content of this BLOB, we can call command git show, and we can add again 5 first letters of this token. It will be, and inside this BLOB we can find the content of our file. It's this is file name, and inside this BLOB we can see this content. So wait, save in the git. Okay, let's take a look on our objects. Again, we are in our objects folder, and what do we have here? We have this BLOB, and the first two symbols in the commit token, it's a name of a folder. So git tries to save place in file system, and first 2 letters it's a folder name, and other letters it's a file name. So let's take a look what we have with 70. Here is this folder. Let's go to 70, and what's inside? And inside we have one file, it's this CEE. Yes, it's what we needed. And let's open it. And here we see that here's some binary information. We cannot read it, but for this purpose we have a git show function, git show command, which will show what's inside. And inside is this binary file. And it's what we can find on git folder. So what's interesting is that usually we don't work with these git folders and the git objects. You don't need it. Everything is handled by git, but in case if you will break something with these folders, for example renamed or deleted, it's very difficult to fix the problem, and usually you need just delete this repository and clone from remote server, clone your remote repository and start everything again. It will be the simplest solution.